Good evening, everyone. Okay, so today we are going to discuss about OOPS concept. But before starting OOPS, let me tell you some things about Python, right? Okay, first thing, Python is not a good programming language where you can start learning OOPS. If you are learning object-oriented programming for the first time, I will suggest you should prefer C++ or Java, right? Because there are some concepts of OOPS which are not correctly, or you can say which we cannot implement in Python, but those are some solid concept of object-oriented programming, some deep concepts. So, now let's start. The OOPS, that is also known as object. Now, okay, different types. We have seen different types of data types, right? We have seen int, float, boolean, um, and string. All of these type of data types are known as primitive data types. These very basic data types are known as primitive data types. Now list, dictionary, tuple, set, linked list, double-ended queue, DQ, priority queue, all these data structures, these are known as derived data structures, right? List, list or dictionary or tuple, those are derived from the primitive data structures, right? Inside list, what we are storing? Inside a list, we are storing integer or string, right? Primitive data types. So list and all these type of iterable that data types are known as derived data type. Now we are going to study about OOPS, and in this concept we will discuss about a topic that is known as user defined data type. As a user, you can define your own data type, right? Now this OOPS, this object oriented programming, these concepts, there are four pillars of OOPS, four concept of object oriented programming. First is encapsulation. We have abstraction, polymorphism, and we have inheritance. We have seen polymorphism, right? We have discussed about polymorphism. Okay. Now let's discuss about encapsulation. See. Okay, leave encapsulation and inheritance for right now. Let's discuss about abstraction. What is abstraction? See, if I have an integer with value 10, right? And if I have told you that print the square root of this integer, so what we will do from math import SQL, and we will print sqrt 10, right? So it will print the square root of 10. Okay. If we want some particular value or method value, put inside that. So this is a particular square root of 10. Now guys see, by the name of this function square root, we know that any value we can pass inside this square root, we will get the square root of that particular variable, right? If I will pass 10.36, we will get the square root of 10.36. We will get the square root of 10.36. Okay, so that is no change. to some code and okay. So see, observe the square root function. There is no need for you to understand how this square root is working. What is the algorithm implemented inside this square root function? How it is working? What type of data it is representing? It is running in the for loop or a while loop is running inside this particular function, or it is providing the solution in login and login time complexity, or it is implementing the logarithmic exponential function. No need to know that, right? Just we know that we have a square root function and we implement that function and we use that function to get our value. This particular concept of providing only the feature to the user. This square root is a feature. It is provided to us. We are the user, right? So only providing the feature to the user and hiding the implementation. See, this is the implementation of square root, and it is hidden inside some other file or function or whatever that is. It is hidden somewhere else, right? This particular concept is known as abstraction, providing the key features to the user and hiding the implementation. That is the concept of abstraction, right? We are using this print function again and again, but we don't know how this print function is implemented, how this print function works, right? We don't know the code of this particular print function, but somewhere in the code this print function is implemented, right? So that particular code, this is also known as abstraction. We are using the print function, we just know how to use that. There is no meaning of sorry, there is no meaning of understanding how this print function is working, right? So this is abstraction. Create something, hide the implementation, hide the algorithm, hide the things how they are working, right? Only provide the necessary features to the user. That is abstraction. Okay. Now encapsulation. Let's go to, okay, suppose if I will create a function here and I will call that function. See, this particular data type a, b, and return value. This a, b, and return value, these data types are defined under the name of my function. Okay, these three values are defined under the name my function. Okay, now see if I will create a list here, a list here. I will create one another function inside function. See, this my child function and all these things are created inside the name of my function. So this is encapsulation. What is the concept of encapsulation? this variable a, b, my list, this another function, my child function, this return value, all these values are packed inside a single name. This is the concept of encapsulation, packing the elements, the attributes, the variables, the function inside one name, under one name, is known as encapsulation. Okay. Now, so I have told you that we have seen polymorphism, right? How come we have seen polymorphism? See, we talked about default parameters, right? So we have seen that how these default parameters works and what are the complication, what are the error prone areas while using default parameters. But let's see how the memory works with for default parameters. Suppose this is my function. I've told you that function is a block of code, right? A block of code. You see, suppose this is my function, a block of code, right? See, for this example, for my function, I have two attributes, right? So, I mean, I have three particular parameters with two default parameters, right? See, if I will call this function by three values, it will work. If I will call this function with two values, then also it will work. If I will call the function with only one value, then also it will work. So how come it's working with all these values? See, same copy of the exactly same function. Three copies of my function will be created in the memory. Right? Three copies of my function will be created in the memory. Right? Now, if you will call my function using only one variable, then this copy will be called. If you are calling my function using only two variable, then this copy will be called. If you are calling my function using all three variables, then this copy will be called. Right? This copy will be executed. Right? You see, the concept of existence of a same function in more than one form. See, this same function, this my function is existing in more than one format. A format which is accepting three parameters. One is accepting two parameters, another one is one parameter. But the function is same. See, the function name is exactly same. The function is same. So existence of a function in more than one form is known as polymorphism. A more generic definition will be existence of a message, a code block, a message or an entity in more than one format, in more than one form is known as polymorphism. Okay, so these are some basic definitions. Now, using the square root or this type of function or print or you creating some default parameters are not a concrete way of implementing all these OOPS concept. To implement these OOPS concept in a better way, in a concrete way, in a more suitable and secure way, we have to use class and objects. We have to use class and objects. Now then again, class and objects is again one more concept. So let's discuss about class and objects. See, these OOPS concepts, right? These OOPS concepts, these are only theoretical concepts. Whatever we will implement, whatever you will do with your project, each and everything will be implemented using class and objects. Okay. Now see guys, let's print the type of A. And if I will do that, see, we got the value float, right? A is a floating point, that's good, got the value float. But see, there is some extra thing is written there, extra keyword, that is class, class float, right? Now, what is the meaning of this class? So we have seen that function is a block of code. We can write multiple elements inside function, and we can write another function inside function. That is also well and good. We have seen that just right. But see, all these concepts will not help us to implement the object-oriented programming. We have to use class and objects. Class and objects are used to create user-defined data types. User-defined data types. Now, whatever I'm going to discuss right now, everything is only in theory. Right? So try to understand. Okay. So whenever you will write a equal to 10, right? Whenever I will do a equal to 10, what happens? Just write down a memory block a of type integer will be created with some value 10 and a. Can anyone tell me what is the size of an integer? What is the size of an integer in byte? How many byte an integer will take? Okay, so an integer takes um, so if you are working with C++, then it depends on your compiler version. An integer may take 4 or 8 bytes. Right? In case of Python, an integer may take 4 or 8 byte. This again depends on the structure of your processor. Right? I think whenever you try to install a particular software, there are two options for Windows 64-bit and for Windows 32-bit. Right? So this 64-bit and 32-bit, this is the structure, this is the architecture of your core, your CPU, right? So see, this 4 byte or 8 byte, there are difference, right? In somebody's system it will take 4 byte, in somebody's system it will take 8 byte. So it depends on the architecture of your system. Okay. So let's for right now let's just consider a 4 byte memory. Okay. Now, okay, think of this. Suppose this is my compiler, right? This is my Python interpreter, and it is responsible for creating this type of memory for holding some values. Okay. Now, who tell the compiler, who tell the interpreter to create a memory of exactly 4 bytes? Who tell the interpreter to store 10 here? Who tell the interpreter that where to locate this memory? Your RAM is a very big memory size, right? 8 GB RAM or a 16 GB RAM, if you will convert that into bytes, it will be like thousands of bytes, right? Okay. So who will tell the interpreter where to look for this particular memory inside RAM, right? Who will tell the compiler that if I will perform some basic operations, see this particular plus equal to, this is known as shorthand operator. It is similar to a equal to a plus 12. Okay. So who will tell the compiler to take out this 10, add 12 to that 10, add 12, perform operation, and then put that value again to some memory location? All these things will be done by the class. The implementation of these is written inside the class. This is a way to create an empty integer. This a is empty right now. If I will print The value of a, it will be nothing. See, nothing means zero, right? So it will be nothing. Now press control, hover over it, click, and we are, see, the representation of int. Class int. A class of integer is created inside function. Okay guys, observe the name of the particular file, builtins.py. Built-in, right? So we have seen that integer is a built-in data type in Python. Float is a built-in data type. If you look somewhere else, then I think you will see float. See, we have float also. And all these things written inside this class. We have all these things written inside this class. uh, Thousands of lines of code. It will tell the compiler that how to create memory, how to delete that memory, how to perform operation on that memory, right? How, what is the size of that memory, how to convert that memory to bytes, bits, whatever that is. Okay. Now, so see, so integer is a built-in data type in Python. Suppose you want to create a data type, and let's suppose that the name of the data type is student. I want to create a data type and the name of data type is student, right? Now, okay, focus here. So what is the role of an integer memory? To store one integer data, okay? Data of 4 bytes, 4 or 8 bytes, whatever that is, right? Suppose I want to create a memory block. I want to create a memory block where I will store roll number of a student. I will store name of the student. I will store address of the student. I will store age of the student. I want to create this memory location, right? So if you can think, well, like we can do the same thing with a list. Suppose create a student name list, and inside this list, let's pass the name of the student and roll number and whatever those things are, those particular requirements are. But guys, suppose if you will, if we have to create hundreds of student, then we have to create student one, student two, student three, like these hundred of students, right? Because if I will provide a name one and name two inside the student, then this student variable, this student list is holding the information of two students, right? But I don't want that. I want a particular dedicated variable only for a single student, a dedicated variable which will hold the data of a single student only. Okay. For this purpose, we have to create a class, right? Now, let's see how to create a class. Let's see the syntax. Class keyword, name of the class. In this case, I am taking student. It's okay if you provide square bracket, sorry, small brackets, and if you don't provide, then also it's okay, right? Now, what we want this class to, I mean, store. What we want. So we want it to store name of the student. Name is of type string. Let's first store. Let's create an empty string. Again, roll number of a student. Let's take it as integer and create an empty integer. Now let's see how a memory for this will be created. See the concept of encapsulation here. All these memory for student name, student roll number, just right now ignore these annotations. Okay, I need to proceed with this annotation right now. Other than that, the name, the roll number, all these things, all these memory is written inside one name. That is the name of a student, the name student. Each and everything is written inside student. This is encapsulation, binding all data under one name. Okay. So this is how a memory will be allocated for a class. Now let's leave the theory for now, okay? Because things are going to get some little bit complicated. First, let's discuss the implementation of a simple code. Then we will see the theory about that. So, creating this name and roll number is not correct. Till now, creating this name and roll number is not correct according to Python. Now, consider a situation. We want to store data about students, right? Now, what will be the data a student should hold? University name, student name, student roll number. Okay, let's take only these two. Now, guys, think of a situation, right? If I will create hundreds of students, right? University name of each and every student is going to be same, exactly same, right? Because all 100 students are studying in the same university. Okay, so the variable, the value which will be shared by all the students, which will be shared by all the different variables of student data type is written inside your class. Okay, now this a equal to 10, this a equal to 10 creates an integer value and provides 10 to that particular value, right? There is a slight difference, syntax difference, when you will try to create a variable for your student class. Okay. So to create a variable for your student class, write the name of the class, then the name of the variable. In this case, let's do name of the variable. So to create a particular student, the variable for a student class, write the name of the variable and give the name of the class. This will create an empty student variable S1, somewhat similar to creating an empty list or an empty dictionary, right? See, list is also again a class implemented in built-in Python file. And there are multiple values, or I mean functions for list, multiple functions for dictionary, and all these things just leave it out. Okay. If I will try to print S1, I will get the memory location of that S1 variable. Memory location. See, this is the exact representation of a hexadecimal memory location. If I have created an integer A, if you want to see the memory location in hexadecimal values, write hex ID A. It will give me the memory value of A in hexadecimal format, the real original format which is used by your system. And I think in first or second class, I've told you that memory, the address of memory is always represented in hexadecimal formats, right? if you want to see this particular value, you have to follow some special syntax. That is, to print the particular value, you have to write variable name dot the particular value you want to see, and it will print the value. Let's just let know. Up till now, is there any doubts how to create a class, how an class variable will be created, and anything related to that? I think it's clear that why we need a class, right? Because see, Python is not a, you can say, a very good language to understand this class and objects or groups concept. So if you are getting things done, we'll move a little bit. Okay, why we create a class? Okay, let me think of a example. Okay, suppose we have some data related to salary of employee, a table data, salary of employee. Okay. There are some different columns related to tax, salary, CTC, some like PF, whatever there is. These are the data. Now, we want some operations to perform on this data. Like I want to calculate tax. So I will write a function named tax, which will calculate tax for this data. Okay. This is some Excel file. Okay. Leave that. This is some Excel file stored in your database or a SQL database. Leave that data. I will create a particular function which will uh, operate on this data and find the tax. Create a particular function which will calculate total salary of a employee. Total salary of an employee after 1 year, 2 year, or 4 year, after a particular gap. So I will create a function for that. I will create a function to calculate the total salary that should be deducted from an employee for his vacations, right? For sick leaves or any type of leaves. So these three functions works on this data, right? These three functions work on this data, and they work. The work of these three functions are separate works, but they are working on the same data. Right? They are working on the same data. Now consider it. Is it a good practice if I will pack all these function inside a big box? I will pack all these function inside a big box. Okay, and I will tell this box, give some instructions to this box that the functions which are present inside this box should only work for this data, no other data, no other data. There are maybe other tables, right? Other datas in your database, some URL, some website data, some other data is employees information, age details, their family details, other details, right? But what I will do, I will create a bigger box, pack all this function 1, function 2, and function 3 inside that box. I will give instructions to this particular box, that all these 1, 2, 3, all these three functions will work strictly only for this data, right? Okay. So this packing of this function inside a bigger box, this is encapsulation. If you are sitting inside this table, if you are sitting inside this table, you don't know the implementation of function 1, 2, and 3. You are only using function 1, 2, and 3 to calculate some tax and whatever there is, right? So this is the concept of abstraction. Okay. To implement these concepts of abstraction and encapsulation, you have to implement class and objects. This is the need of class and objects. Okay. Now let's move. Let's move one way, right? Another level. So in this time, what we will do, instead of some database, suppose we are the only person who are creating data. Yeah, we will create a function within a class, and shortly we will see how to call a function within a class, right? Let's first clear this topic. Now, okay. Now leave database and leave all those details of employees. Suppose we have to create a solution, a software which will create or gather this data, this employee data. So this time what is happening? We have to create a data. Sorry, we have to take a data. Now we have to write different functions which will operate on this data. Function 1 to perform something, function 2 to perform something, function 3 to perform something, right? Now, is it a good practice if I will combine all these things and write this inside one box, right? Inside one box. Now, these functions are restricted. If I will create this box, these functions will be restricted to work only for this data. No, these functions cannot work with another data, right? Suppose I have another particular class here, sorry, another particular box here, and inside that box there are some other data are there, right? There are some other data. So these function cannot work with these data. Why? Because we cannot communicate between one box and two box number 1 and box number 2, right? Yes, we can create multiple objects of one class. I think guys, the concept of why we need a class, what is encapsulation, abstraction, and this particular method, it is a type of, you can say, uh, an architecture of creating a program, creating a solution, an architecture of creating a solution where you are binding your data and the functions which will work on that data together, right? You are binding the function and the data together, right? This is a type of architecture. Now, so this particular bigger box, this is your class. This particular data, this is your variable inside that class. We have just created this university variable. So this is variable inside that class. Now there are some technical terms. A variable inside a class is known as attribute. This university variable now called as attribute, right? A function inside a class is known as method. Okay, these are only the technical terms. There is no difference between a method and a function. Function do the same work as a method. Method do the same work as a function. Just the difference is that method is bounded with some special type of data, and functions can operate on generate data, whatever type of data a user can provide. Okay, no, yeah. So see, now the question is there: can we create multiple objects for one class? See, I have created an integer b. I have created an integer c. and I have created a list D with some integer data types, right? Execute, and it's well. Right? So see, these are multiple variables of same class, integer class. So we can create a multiple objects of a class. There is no problem with that. Okay. A is a variable of integer class. B is a variable of integer class. C is a variable of integer class. D is a list of integer class with multiple integer class data. That's good. Now there is one more technical term. A variable, when we create a variable for a class, that particular variable is known as object. This S1 is known as object, right? This S1 is known as object. Okay. Now let's see how these objects are created. Yeah. Let me do one more thing. Now, see, no memory for a class is defined now. Right? This memory for the class is defined to hold only the university variable. Okay, university variable and nothing else right now. When we create a S1, see what is written here: student instance. Okay, student is the name of the class, and this instance, you can say object and instance are the same word used. Use the term instance or use the term object as you like. Okay, student, you can say student object and you can say student instance. S2 is again the student instance. Okay, now I'm trying to print S1 dot university, and there is only one university that is created in the memory. There is only one university created in the memory. Right? So what happened if I will print student 2 dot university? It will again print the same university value, because we are trying to access the same university variable by using two different object S1 and object S2. This is a typical, you can say, uh, a memory management by Python. So let's understand how it's working. Now we are clear how to create a class and how to create objects of that class. Now inside a class, we can create methods. Inside a class, we can create methods. Methods means functions. S1 and S2 are in different memory location. Objects are in different memory location, right? S1 object and S2 object are in different memory location. Okay. But this university attribute is shared by both S1 and S2. Both are sharing the same attribute. Okay. Now, so we have some methods. Okay. See, there are two types of attribute. There are two types of attributes. One is known as class attribute. One is known as class attribute. And suppose if we will create an object if we will create a object, and in future we are going to understand a particular object attribute. So there are there is a concept of object attributes, right? Now understand one thing. As you can see, there is three memory allocated here. Memory to student, that is our class. Memory to S1, memory to S2. Okay. If I will remove this university from here, and suppose I will create a just define a function, basic function here, right? And let the function do nothing. Okay. See, student will get some memory. This student class is getting some memory to store its code, not data, to store its code, right? After that, we have to create object for this particular memory. I mean this particular class. We have created student 1, student and student 2, right? So there are two concepts. One is class related, I mean the class attribute and object attribute. The variables, the attributes which are written inside class are known as class attributes. They are bounded with the class. They are binded with the class memory. If I will create, if I will create 200 objects, all these 200 objects will access the same class attribute. All these 300 objects will access the same class attribute, right? And same class function, all are going to access the same class function. Okay, but a object 2 cannot access the attribute of object 1. Now what is going here? See, okay, if anyone is taking notes, note this down. Class is a blueprint. Class acts as a blueprint to create memory. Class acts as a blueprint to create all objects. Objects are defined to access different elements of a class. Attribute is an element. The particular method is an element. If you will create a class inside another class, which is not recommended, ID not recommended, okay, to write a class inside another class. But if you will create a class inside another class, then a object of the this bigger class can access this particular class. Okay, so what is a class? Class is a blueprint, and object is the implementation of that particular blueprint, that class, right? So this university written here, it is a class attribute. It is a class attribute, not a object attribute. So if I will create one more object S3, that is our student 3, what it will do? It will again print the same value. Right? So we are only accessing the university attribute. We cannot change the value of student, I mean university attribute, using some different object. It cannot throw any error, right? But the meaning is different here, right? If I let me execute this one. See, the university for a class is different, but the university for S3 is different. Memory performs after creating instance or not. See, there is a you are only answering your question, right? Memory allocation is performed when you create an instance, when you create an object, but we need memory to store that function, right? We need a particular memory block to store code for your class. We cannot insert some data inside that memory, but we need memory to store your class, store the functions inside that class, methods inside that class. So we need memory for that, not to store values. If you want to store any value inside a class, you have to use objects. Right? See, this S3, it is creating a particular memory for storing university and its value hello. But we have created this university, right? Class attributes. So whenever you will create a class attribute, memory will be given to that class attribute, right? There is no need for an instance here. If you are using or creating any class attribute, memory should be given to that particular class attribute to store, right? Now see, so I've changed the value of university, right? Now let's see what is the output. If I will do s2 dot university, then again I will get the value as my university. The value is not changed to hello. Why? Because when we do s3 dot university and create a new value, a new memory for that s3 is created. It doesn't change the value of your class attribute, right? So to directly interact with a class attribute, instead of an object, write the name of a class. Now the value of university will change to hello, right? So if you want to interact with a class attribute, you want to change its value, you want to access it properly, use class name dot attribute name. Accessing class attribute, right? Now how to create object level attributes? See, if I will create s1 dot name, so this s1 dot name, it will create a class level attribute for object s1, only for object s1. If I will print s2 dot name, it will throw me an error. See, student object has no attribute name. For which line? Line number 16. Line number 15 is okay, right? But if I want to access the student one dot name, it will give me the output, right? So this is how you will create particular object level attributes. See, this is object level attribute, right? This is a object level attribute. See guys, if you have studied object-oriented programming in any of the language, C++ or Java, I will suggest that forget about each and every single concept you have learned there, because the object-oriented programming is in Python is entirely different, right? Now, if I will create s2 dot age 12, right? And now if I will try to print s1 dot age, will I get an error or I will get the value 12 for this particular line? For this particular line, I will get a value 12 or an error. See, oh, I have not created s2. S1, S2, some value to S1, some value to S2. Now guys, this particular age is only defined for S2. If I will try to print the age using S1, I will get an error because there is no attribute named as age for S1, right? So in this case, I will get an error, the error that attribute error, object has no attribute age. S1 object has no attribute age, right? But if I will print using S2, that's well and good. So with this example, we have seen a typical logical error, typical logical problem. Suppose this particular class student is abstracted, right? It is defined inside some file number 1, and we are now writing, we are going to write program in file number 2, right? Some different file, right? So the first step, what I will do, I will create an object 1 of class student. I will create some attribute for this object 1, name and age, and some roll number, right? Okay. Now there is another programmer, another user who will create a object 2 named student, right? And he will create object 2 dot address, and he will create only roll number. Now look at the data. One object means one student, student 1 is holding the details about his name, age, and roll number, while student 2 is holding the detail about his address and roll number only, no name and no age. So if you will give power to the user to create their own data, own object type data, sorry, object level attributes, then there will be an inconsistency in data. Data saved for a user, data saved by user 1 may not match with the data saved by user 2. User 2 only save this much data and user 1 will save this data, right? So there is a form of inconsistency in data, right? Okay. So to restrict these, we have to create object level attributes inside our class in such a manner that whenever a object will be created, different types of object level attribute will be created then and there to use, right? There will be no use to create object like these using hard coding. Okay. So let's see a new concept of constructors. Okay. See now, what is constructor? So constructor is a special type of method, right? It is a special type of method, and there are some special rules with constructor. So that is, this is the name of the constructor. You cannot change the name of the constructor. Double underscore init double underscore should be the name of the constructor of a class. It is double underscore, right? Okay. And it is a rule that your constructor cannot return anything. As constructor is a method, we have seen that method can return some data, right? But a constructor should not return anything. Okay. The name of the constructor should be init, nothing else, right? A class can contain only one constructor, not more than one constructor in Python. Okay. Yeah, in Python, class name and constructor names are different. Constructor names should be init. Okay. Now, what is this constructor? How does it work? So whenever you will create an object for a class, whenever you will create an object for a class, this constructor method will be executed by the interpreter. No need to call this particular function. We have seen that we have to call a particular function to execute that function, right? But for constructor, whenever you will create an object, then and there the constructor will be created by the interpreter, sorry, called by the interpreter. Okay. Now let me give you an example. Now, what is this parameter self? It is not necessary to name it self. You can name it anything, A, B, C, D, whatever you want. But it is, you can consider it as a convention to write self. The first parameter in any of the methods in a class, any method I will define inside this class, the first parameter should be self. Okay? Now, let's see how this works. Yeah, we will see what is self. See, some data will be given to this university, some memory space. Some memory space is given to the constructor. Okay. Now, see, I want to create student one. I'm not calling the constructor, but see, the compiler will call the constructor itself. And see the name of the self. What is the name of this self? What is this self is doing there? See, self dot name, a name will be created. Self dot age, a age will be created. Self dot role, self dot add, everything will be created. Return value is nothing. It is compulsory that there will be no return value inside a constructor. When I will end this, when I will end this, see what this self has done. It has created the memory values, created memory for all these name, age, roll number, and address, and assign that memory value to S1. Assign that memory value to S1. Now, what is this self? So, This constructor is called during the construction of this object S2, construction of object S1. When you will create a object S3, then also this constructor will be called. You will create a object S4, then again this constructor will be called. This self determines which object is calling the constructor. Right? This self determines which object is calling the constructor. Consider self as the object itself. Yeah, constructor is always called automatically. The technical term for that will be implicit call. Implicit means the interpreter calls the constructor. No need for the user to call the constructor. Constructors are executed by implicit calls. So this self defines the object S1 is calling. So that's why self provides all the memory to S1. When this S2 will call, then again this new self will create all the memory. And see what this self will do after execution. This self will assign all the memory to S2. Okay, what is self? Self is a copy, is the instance of the object, copy of the object. This object is given as an parameter to your constructor. This self is S1, this self is S2 when while creating S2. Okay, now so what just happened right now? Okay, let me remove this. Remove all these. Accessing class attribute, creating objects. Okay, it's feeling good. Now, no need for these. Now, whenever I will create S1 and S2, see, whenever I will create S1 and S2, all different types of memory for name, age, call number, address, whatever that is, were created by the constructor. All the essential object level attributes are created by constructor. Now I have to provide the values. Okay, what will be the output of this print statement? Just take a guess. Age attribute was created for S2 also. So let me know the output of S2 dot age. Okay. So as you can see, if we will not provide any value to any integer, it was defined as the value 0, initialized with value 0. The best example is here. I have not provided any value to A, and I will try to print A and it will give me answer 0. Okay, so if you will not provide any value to any type of integer, it will be initialized with value 0. If I will try to print the age, I will get 0, not error, because when I was creating the object S2, this constructor was called. And see self.age. Self.age means S2.age. Age was created for S2 as type integer. Right? It is clear that what is the role of this self. Okay. If I will do S1.age, then just right now I have provided some values of value 23. right? Now, there are different type of constructors. Okay, in general concept of object-oriented programming, class and objects, you can change the self parameter to another name or yes, change the self to a, no problem. No problem with that. Just the naming convention is self, so always use self. Okay, now what was problem here? Yeah. So in general form of object-oriented programming, class and object concept, there are three types of constructor. Default constructor, this is an example of default constructor. Okay, there is a type of constructor which is known as parameterized constructor, and there is a type of constructor which is known as copy constructor. Right? In Python, there is no concept of copy constructor. Right? Copy constructor does not exist in Python. Okay. Now let's see what is parameterized constructor. So as I told you that there will exist only one constructor inside a class in Python. So I have to comment out this one, or otherwise I will get some unexpected behavior, not error, not an error. See, a particular constructor is a function, right? So if a constructor is a function, we can pass as many number of parameters as we want, as many number of parameters as we want. Right? Okay. me let me show you one more concept of args and quarks in function. This particular concept is related to function, not class or object or methods. No, it is related to functions. Now, what is this quarks? So name can be anything, but using quarks is convention, naming convention. Okay, but the syntax, these double asterisks, this is required, right? It is a syntax. So what is the meaning of this quarks? Using quarks, we have seen that we can call, okay, let me take the example. We have seen that we can call this function using by taking maximum of 4 parameters, right? And we can define the minimum by using default parameters, but we have to use maximum of 4 parameters. What happens if I will use 5 parameters? I will get an error and it will say 4 positional arguments are required, but 5 were given, right? But if I will use args and I will provide as many number of values as I want, right? I won't get, wait, W is not defined, single quotes. W was taken as a variable, not a string. Now, yeah, I will not get any error. Why? See, first 5 values or 4 values, whatever that is, are assigned to A, B, C, and D. All other values other than that is passed to this args as a list. If I will try to print this args here, it will be printed as a list. See, not a list, a tuple. In this case, tuple, not a list, a tuple. Sorry. Right? Now, instead of args, if I will be using quarks, right? In this case, I might get error. Yeah, this error. So see, args accept all these parameters, all these arguments as a list, but quarks accept all these arguments as a key value pair, as a dictionary, right? As a key value pair. So if I will do CT, I will do, let me remove all these beautiful things. Uh, Equal to this, or f equal to some other value, or g equal to some other value, h equal to, I mean, any type of values, or you can provide I equal to a list of some values, right? We won't get any error. And see, what is quarks? Quarks is a dictionary. A dictionary which is holding excessive arguments, extra arguments, right? This quarks is holding extra arguments. This 10, 20, 30, and 40 are passed to A, B, C, and D. All other arguments are converted to a dictionary, then passed down to the quarks. Is the concept of quarks and arcs are clear? No. Let's take different parameters as quarks. Okay, first of all, let's not make it more complicated. Let's take simple name, age, and roll number. Right now, what we are trying to do, assign, create an object level attribute name, and assign the name coming from the particular uh, parameter, formal parameters, and assign that value. Dot each self dot rule. Now, now I will get an error. Why? Because this constructor is expecting three values: name, age, and roll number, and I have to provide that values. So where should we provide that values? Inside this small brackets. First is name. Let's provide age as 23, name as and roll number as 23. Name as unit, roll number as 13, which is 22. Now it's okay. No error, right? And the values are assigned. If you want to check the values, print s1.name age. Is this concept of parameterized constructor is clear? So guys, let's just take a small 2-minute break. Okay, I have to charge my laptop. Just let me plug in the charger. No, self is not a default parameter. See, sending this S1 object to this self, it is the work of the interpreter. Okay, not a programmer, not a user. This S1 will be sent to this parameter self by the interpreter. Okay, it is not a default parameter. For default parameter, you have to provide a value here, right? And we have seen that the default parameter is always written to the last of the parameter list. Yeah, so it is a targeted function call. We have seen this concept. See, we are calling using B, A, and then C. No problem with that. It is known as keyword argument function call. Okay. You have to target the particular parameter name where you have to send the value. Then it's okay. You won't get any error. Okay. Any more questions, right? See, it is not very easy to understand class and objects concept in only one class. Okay, but try to build your base. We have to use self for each and every method which is written inside a class. The first parameter in each and every method should be self. It is necessary. If I will create a display function here, I have to give self, right? And what is the use of this display function? Let's print the name. Okay, let's create a string name info. Let's take a formatted string to name of student self.name slash n roll. Plus n. Next we have uh also age and address. Okay, in this case we only have age. So instead of printing these like this, yeah, always self dot variable name, self dot attribute name. It is not referred as variable, it is referred as attribute. Okay, self dot attribute name or object dot attribute name. If you want to access that attribute, object dot attribute name. If you want to access a class attribute, it's class name dot attribute name. Okay. Now, how to call a class method? How to do that? So it's similar as accessing the variable name, just object name dot method name. That's it. And if that method is expecting some parameters, you have to pass that parameter similar to a function call. That's it. This S1 will be passed to this self by the interpreter. Okay. You don't have to provide some value here for this cell, right? You see the output. See, this is done by calling this display method, right? Is it okay? How to call a method? Okay. Now, let's look at the concept of a copy constructor. See, what is the role of parameterized constructor? It accepts some parameters. Accept some parameters. That's it. Default constructors, it doesn't accept anything other than self. It doesn't accept any other parameter. Right? What is the role of a copy constructor? Suppose I have a student S2, a object S2, and I want each and every element of that object to create a new object S3. So I cannot do this S3 equal to S2. I cannot do this. We have seen that, see, objects are mutable in this case, right? Class objects are mutable. In this case, class objects are mutable. So if I will do S3 equal to S2, it will then point to the same memory location, and any change in S2 will be reflected to S3. So we have to use deep copy. Not a shallow copy. Okay. We cannot perform a shallow copy because there are multiple memory locations in multiple levels. So we have to perform deep copy to copy all the levels. Okay. So to achieve the similar result as a copy constructor, use deep copy. Right. Now guys, using these types of parameters is not a very good way. I mean, you can do this and this is also used, but it is not a very good way to create a constructor, class constructor. So let's see a more discuss about a more generic term of a constructor. So define init. Instead of values, let's accept quartz. And quartz is just a name, so let's take it as values. That's good. Self dot name val. Okay. Are you guys? Did you guys remember the methods of dictionary? Get and set or default. Get and set or default. I mean set default. Let's take set default. Right. Now, what we are expecting a key name. Okay. And then let's think the default particular default value, and the default value, if no value will be provided. Yeah, that one is also possible. That particular S1 is equal to student ABC 3435, that is also possible. Constructor is nothing but a special function. So the particular name will string will go to name, and values, integer values will go to age and roll number. No problem with that. Right? Yeah. Set default. So we have a key of name, and if name is not given, let's provide no name. Right. If we will execute this one, name is not defined. This one. Okay. See, this is a use of dictionary based, or you can say quarks based function call. Suppose you are a user and you are creating an object only with name, and you are not providing age. Only with name and you are not providing age. Or someone is only providing name and not age. I mean, not roll number and only age. There are maybe various possibilities, right? So instead of creating this particular values, suppose other user, one more user is providing address. One more user is providing address, right? And let's give the address as 123 street. Okay. Now, all these values will go to Quarks as a set of key and value pair, right? Say Quarks will only accept keyword argument function calls, right? This type of function calls. It won't accept this type of function calls, normal function calls, default function calls, right? Whenever there are quarks present in your particular function, always use keyword argument function calls. Now, this sector report, let's copy this one instead of name, age, phone number, address. And roll number should be an integer. So instead of this, let's provide -1. Age will be integers. Let's provide 0 if no age will be given. Now, this will throw an error. Why? Because if you are providing age to some object and providing address to some object, we are trying to access age of the object. And if no age will be provided to that object, we will get an error. So instead of this format, let's choose a more robust one. That is if self.age. Suppose if self.address, right? Let's create a info string, empty string. If self.name, right? We have to take info plus name. If self.age, we have rule address. And that's it. And print info. Right? It's all display. Okay, okay. Our number was taken as string, right? Let's convert the roll number to first. Age is also given as a string. Let's convert that to str and convert roll number to str. And display. Okay. So these are the particular values we have, right? And we're not getting any error. Why? Because before accessing the particular value, we are checking inside if condition that that particular value exists for the object or not, right? your address, your name, zero knowledge. Because for this one we have name, age, number. Yeah. We have all the values and different things are there, right? So guys, up till now, do you have any problems or any doubts about how Quartz is working and how to implement these things? After this one, we will see some particular functions, some special type of methods for a class. Okay. Suppose you are a new user, right? And suppose I'm working in some other file. Okay, I will create a object one for student class, and I don't know how many variables are there, how many attributes are defined for object one. So what I will do, I will print the dir directory for object one, and let's see what it will provide me. It will provide these many attributes and different types of functions we have. Okay, now these double underscore functions, these are known as dunder methods, and those are special method in Python, right? These are defined for each and every type of classes, and these are special methods. Okay, the attributes and methods that we have created are written at the end. A- Add, age, display, name, roll number, university. All these are attributes and methods that we have created for this particular class. Okay, now there is one more option. Can print it. Yes, assuming it is a part of inspect dot yes, and I have to create an inspect. So let's take the inspect. Okay. Now this get member is another method which will provide all the different types of attributes and everything with their values which is associated with your object. Name, we have created an attribute for S1 name with some value, roll number with some value, university with some value, right? Okay, so that's why we are getting all these values. We have values no name, 0 and 1. See, if I will comment about this one and comment this one, that is now our constructor. In this case, now I will get an error. But, okay, this one, object one, object Now for this object one, I will get an error. Why? Because in this case, we are calling this particular parameterized constructor and I am not passing any values, right? But when we are using that quarks, when we are using this quarks, there is no matter if you pass any value, that's well and good. If you're not passing any values, that's also good. It will create the particular function, that particular object for you. Object with default value, see. Object with default value, university, hello, roll number -1, name, no name. And there will be some address that will be written. So it is lexicographically sorted. Yeah, we have name, no name, age, 0, roll number -1, all that. Right? So these are two different or three different functions, methods used to get the particular variable names or object names. Those are associated with an object, right? Attributes names. Okay. Now let's talk about a special type of method that, see, we have seen this in it, right? Let's use this str, right? See, to print a particular object, I have to call display function, right? But if I don't want to call the display function and I want to only print using print statement, print s1. In this case, I will get the memory address of s1, right? Instead of that, instead of the display function, let's implement a more generic function which is given by Python. Okay, let's comment out this constructor, use this constructor. Okay, and it is not having address, so let's remove this address. We'll provide some default values. Default values, age will be 0 and for roll number that will be -1. That's good. Okay, so we have to implement the under method string str, right? See, it is again accepting self. Okay, why? Because an object will be passed to this self. Now, what is the role of a string? It is again a function which is called by your interpreter. It activates on a implicit call. And how a string is called? Whenever you are trying to print, whenever you are trying to print an object using print statement, print function, print method, this string will be executed. Let's create an info. I have created the info, right? Create an info string. And the work of this method is to return this string. And say now if I will execute, I will get that information string using this print statement. Earlier what? Earlier I was getting the memory address, but now I am getting the values of that S1 object. Same goes for this object. We will get the values. Okay. So this is standard method. Double underscore string. Okay, guys. So let me revise the topics. Okay. We have discussed about class. First of all, we have discussed about different concept of hooks, encapsulation, abstraction, polymorphism, inheritance. We have not discussed about inheritance because inheritance in itself is a very big topic. Right? I mean, it nearly requires about 1 to 3 months to only discuss or study about inheritance. There are total 7 types of inheritance. Python does not support all 7 inheritance. It supports some and some not. There are some uh, limitation of supporting inheritance in Python as compared to other languages and blah blah. There are many things. Okay? Now, see, So we have discussed about encapsulation, abstraction, and polymorphism. Encapsulation means we have binded all these methods, attributes, and different things under one name, that is student. Under one name, that is student. So this is encapsulation. Abstraction, hiding all these implementation and providing only the necessary requirement to the user. Okay. Providing only the necessary requirements, the necessary features to the user, right? That is encapsulation. Sorry, abstraction. Okay. Encapsulation was binding, data binding. Now, polymorphism. Existence of a message in more than one form is polymorphism, right? Okay. Now, we have seen that there is a particular special function which is known as constructor. Constructor is always written, the name of the constructor is reserved, that is init, right? There are two types of attribute: class level attribute, class attributes, and object level attributes, which are defined inside constructors, right? It is a good practice to define these attributes inside constructor. Okay? There are two types of constructor: default constructor, parameterized constructor. One more thing, constructor is a special type of method, and it is compulsory to provide self, the first parameter, to each and every type of method you declare in Python. Now guys, let's see some of the good documentation from which you can prefer to learn about Python and to revise your concepts. One of the site is the Python docs. This is the documentation itself written by the Python developers, the person who have developed Python, right? The programmers who are contributing to Python, right? Just search about anything, like search about classes. Class. And it will let's this. And it will give you the particular documentation, written documentation, how to use class, what are the important properties, all these things, arguments, different arguments, what is the use of this particular triple dots, right? Yeah, one more thing, we have discussed about the class attributes, right? There is one more concept, that is class methods. Methods which are reserved for a class, not for objects, but for class, but for classes. Okay, see, this is implemented here. This is implemented here, right? So let's create a class. Let's create a method which is reserved for the class, and that method is created by using method rate static method. This @static method keyword, this particular @static method, this type of syntax, it is known as decorators. Now, what is a decorator? Decorator provides some special meaning to a function or a class. Decorator will provide some special meaning to a function or a class. Now it is going to provide special meaning to this particular function, and let's create a function like this university. It doesn't need anything. It will just print university. Oh, you cannot access university without the class name, right? See, it doesn't require self or any type of parameter, right? Yes, you can pass as many number of parameters you want, but it is not bounded to get only self, right? Why? Because this is a static method bounded to a class, not to an object. Methods which are bounded to an object, binded with the object, uses self to accept that object. See, if I am calling this string, it should know that object s1 is calling that string, object s2 or object s3. That's why it will use self. But a class method is always called by the class, student class, right? Object, right? Hello, I have changed the value. Okay, I have changed the value, right? So this is this particular method. It is a class method binded with the class. Other methods which are written without the use operator are binded to a object, right? Let's see what else we have. And this is a very long documentation. If you have enough time, you can go through these. Okay. Now let's search about dictionary. Okay. So we have discussed about dictionaries. Not this one. Data structures, dictionary. See, list is there, append, extend. Also, we have not discussed extend. Insert, remove, pop, range, clear, many more methods are there. Like list, and after list there should be tuple sequences, sets, dictionaries. Yeah, dictionary is, and we have different types of methods in dictionaries, deleting a particular value and using dig to create an empty dictionary, right? Now we have just discussed about quirks and args, right? Let's see. See, asterisk args are used to take multiple arguments as a tuple, okay, and quirks are used to take multiple arguments as dictionaries. So you can go through these only, right? Yeah. Now guys, let's go to command prompt. Okay, if you have Python installed on your system, you will get the version of the Python, right? Now there is one more thing, that is pip, right? What is this pip? It is the Python package manager. There are various types of, you can say, libraries or packages which are developed for Python. For example, we are using we are using math, right? We are using from math import square root or float. So this math is installed on your system by default. It comes with the Python itself, right? So from date time import date time, it again comes with the Python itself. If you want to print date time dot now, and it will print you the current but function, and it will print you the current particular date time with minutes and also with seconds, right? But suppose there is a very famous package in Python, that is pandas. I want to import pandas as PD, right? Okay, so in my system, I may have installed pandas. Yeah, so pandas are installed in my systems. They are used to install libraries or packages. Pandas are installed in my systems. So maybe in your systems, pandas are maybe not installed. So how to install this particular package? How to download that particular package? You have to write pip install pandas, right? And it will install the particular package for you. For my system, it states requirements already satisfied because I have installed pandas, right? To uninstall some package, type pip uninstall pandas, and it will uninstall that particular package from your system, right? Okay, so these are some of the features of Python. You can use work with pip, okay, to install various packages, command prompt to talk with your Python. Okay, so that's it for today, guys. And if you are having any doubt, right, if I will now I will try to run this one. It's not giving an error. I think I have to remove the temporary file. Okay. If you're having any doubts, then let me know. Otherwise, that's it. We will close the session.